The art of papermaking spread slowly outside of China, reaching Korea and Japan by the 6th century. By the 11th century, it had made its way to the Islamic world, where it was refined and mass-produced. Paper mills emerged in Europe in the 13th century, notably in Spain and Italy, significantly impacting the European Renaissance. This era witnessed the transformation of papermaking from an artisan craft to a mechanized industry, especially after the invention of the printing press by Johannes Gutenberg in the 15th century. Today, the global demand for paper and cardboard stands at approximately 400 million tons per year, showcasing paper's enduring relevance in the digital age. Its versatility is evident in its various forms and uses, from books and artworks to packaging and hygiene products. The evolution of paper from a luxury item to an everyday necessity underscores not only human innovation, but also the need for sustainable practices in its production. Thus, the story of paper is not just about a material, but about the advancement of human culture and knowledge. So how is it made? The production of paper starts with two primary raw materials: wood and recycled paper. The type of wood used is predominantly softwood, such as spruce, pine, and fir, which provides long fibers that give the paper its strength and flexibility. Hardwood trees like birch and eucalyptus are also used, contributing shorter fibers that enhance the smoothness and opacity of the paper. These trees are usually sourced from managed forests, where sustainable forestry practices are employed to ensure a continuous supply without depleting natural resources. The sourcing and harvesting of wood utilize advanced machinery that is designed for efficiency and to minimize environmental disturbance. Machines like feller bunchers or harvesters are commonly used and are equipped to cut, remove branches, and cut off the top of the trees in one continuous process. These machines can process trees rapidly, sometimes in mere seconds, which greatly accelerates the harvesting process. Feller buncher machines, in particular, are highly productive, with some capable of felling up to 100 trees per hour, depending on tree size and forest density. After the trees are felled and processed, the resultant logs are then quickly moved to processing areas using forwarders or skidders, designed to transport large volumes of timber while reducing ground impact. The logs are subsequently loaded onto specialized trucks or conveyors and transported to paper mills for further processing, showcasing the efficiency and integration of modern forestry machinery and logistics. Once harvested, the wood undergoes an initial treatment process. The logs are debarked using drum debarkers or Rosser head debarkers, which spin the logs against one another or against a stationary tool to remove the bark efficiently. The removed bark, rich in organic material, is often repurposed for landscaping or as biomass fuel. The debarked logs are then chipped into uniform sizes, usually about an inch in length, using a disc chipper or drum chipper, which slices the wood with sharp blades or knives. These wood chips are subjected to rigorous quality checks to ensure they meet specific standards in terms of size, moisture content, and purity. Any non-conforming chips are removed from the batch. In addition to wood, recycled paper is another significant raw material. The use of recycled paper not only reduces the demand for virgin wood pulp, but also lessens the environmental footprint of paper production. Recycled paper is collected from various sources, including discarded office paper, newspapers, and cardboard. It undergoes a sorting process to remove contaminants, such as plastics, metals, and other non-paper materials. This stage is crucial, as contaminants can hinder the recycling process and degrade the quality of the finished product. The sorted, recycled paper is then pulped, involving a mechanical or chemical process that breaks down the fibers, creating a slurry that can be further processed into new paper. Throughout the raw material preparation phase, both wood and recycled paper undergo several quality inspections to ensure that the pulp produced meets the desired standards for paper making, setting the stage for the next phase of the production process. For wood chips, the journey starts in a machine known as a digester. Here, the chips are cooked under high pressure in a solution of water and chemicals, typically sodium hydroxide and sodium sulfide. This chemical cocktail, often referred to as white liquor, breaks down the lignin, the natural glue holding the wood fibers together, without damaging the cellulose fibers. The process, called craft pulping, typically lasts a few hours and operates at temperatures around 170 degrees Celsius or 338 degrees Fahrenheit. The end product is a brown soupy mixture called pulp, containing both cellulose fibers and residual chemicals. The next crucial step involves washing and screening the pulp. Washers, usually drum or disc filters, clean the pulp by removing spent cooking chemicals and dissolved lignin. Screening, done through vibrating or rotating screens, removes any larger, uncooked wood particles or impurities. This process ensures uniformity and cleanliness in the pulp, crucial for high-quality paper. For recycled paper pulp, the initial processing is slightly different. After sorting, the recycled paper is mixed with water in large pulpers. In the early stages of pulping, a system known as a ragger is used. The ragger consists of a rotating wire or string within the pulping container, designed to catch and remove larger contaminants such as plastic, cloth, and other non-paper materials. This ensures that only paper fibers continue through the process. Gentle agitation in the pulpers then gradually breaks down the paper into individual fibers, creating a slurry. This slurry is further processed by passing through screens to remove smaller contaminants like staples or plastic fragments. In some cases, a process called de-inking is applied, especially for printed paper. De-inking involves adding chemicals like surfactants and soaps to the slurry to detach ink from the fibers. Air is then blown into the mixture, causing ink particles to attach to bubbles and rise to the surface, where they can be skimmed off. This process enhances the brightness and purity of the recycled pulp, making it suitable for paper production. Both types of pulp, virgin wood pulp and recycled paper pulp, are then subjected to further refinement. Refiners are machines that beat the pulp, improving fiber bonding potential and paper strength. The degree of refining affects the paper's final properties, such as its texture, weight, and strength. Once the pulp is refined, it is ready for the main manufacturing phase, where it will be transformed into paper. This initial processing phase sets the foundation for the quality and characteristics of the final paper product. Historically, paper machines were much smaller, narrower, and shorter compared to their modern counterparts. The earliest paper machines, developed in the 19th century following the invention of the Fourdrinier machine, were revolutionary but limited in scale and speed. These early machines laid the groundwork for continuous paper production, but they could only produce paper at a fraction of the width and speed of today's machines. As technology progressed, paper machines grew in size and complexity. Today's paper machines are engineering marvels, longer, larger, and wider, capable of producing vast quantities of high-quality paper at unprecedented speeds. Some of the largest modern paper machines extend over hundreds of meters in length, have a width of up to 10 meters, and can produce paper at an astonishing speed of 2,000 meters per minute, dwarfing their historical predecessors. The cost of constructing these mammoth machines can be astronomical, often reaching hundreds of millions of dollars. This evolution reflects not only technological advancements, but also the growing global demand for paper. In the current phase, the journey begins with the preparation of the pulp for papermaking. If the pulp is too dense, it's diluted with water to reach the right consistency. At this stage, the pulp mixture typically contains about 99.5% water and 0.5% fiber. This step is crucial as the pulp's concentration directly affects the paper's thickness and quality. The prepared pulp is then fed into the paper machine, a remarkable piece of engineering that typically spans between 150 and 300 meters in length. The first section of the paper machine is the head box, which plays a pivotal role in paper formation. The headbox evenly distributes the pulp onto a moving, continuous screen, called a wire or a fabric. Here, water starts to drain from the pulp, leaving behind a mat of interwoven fibers. The uniformity of the pulp flow from the headbox is critical to ensure even paper formation and consistent paper quality. Next is the pressing section, where the paper mat passes between large rollers that apply pressure to squeeze out more water. At this step, the mixture typically consists of approximately 80% water and 20% fiber. These rollers, often covered with felt, not only remove water but also begin to consolidate the paper mat. The pressing section is a balancing act. Too much pressure can crush the fibers, reducing paper quality, while too little pressure leaves excess water, affecting the drying process. The paper then enters the drying section, which is typically a series of steam-heated cylinders. As the paper wraps around these cylinders, the heat evaporates the remaining water. The number of cylinders and the temperature are carefully controlled to ensure the paper dries evenly without over-drying or scorching. In some machines, a group of cylinders is followed by air-drying sections, where hot air is blown onto the paper. This combination of cylinder and air drying achieves the desired moisture level in the paper. After drying, the moisture content of the paper is significantly reduced, typically to about 5 to 10% water, with the rest being paper fiber. The paper may then undergo a process called sizing. Sizing involves applying a starch solution to the paper, which improves its writing properties and resistance to water. The paper is then passed through a series of calendar rolls, which are highly polished steel rollers. The pressure and heat from these rollers smooth and compress the paper, giving it a uniform thickness and a smooth surface. At this stage, the paper's formation is nearly complete, but quality control is paramount. Continuous monitoring ensures the paper maintains the desired weight, thickness, moisture content, and smoothness. Samples are regularly taken for more detailed testing in the lab. Any deviations in quality are quickly addressed by adjusting the machine's settings. For papers requiring a coating, such as high-quality printing paper, the next step is the coating section. Here, a mixture of clay, latex, and other additives is applied to one or both sides of the paper. Coating enhances the paper's brightness, smoothness, and printability. The coated paper is then passed through a series of dryers to set the coating. Once the paper has been formed, dried, sized, and possibly coated, it moves to the reel section, where the continuous sheet of paper is wound onto large reels. These reels can be of substantial size, often reaching up to 12 meters in width and weighing several tons. The diameter of these reels can span several meters, capable of holding miles of continuous paper sheets. The sheer size of these reels is a testament to the efficiency and capacity of modern paper machines. The winding process must be tightly controlled to maintain paper tension and avoid wrinkles or breaks, ensuring consistent quality. The final step in the main manufacturing process involves converting these large reels of paper into more manageable sizes. The reels are transferred to a winder, where they are precisely cut into smaller rolls or individual sheets, tailored to meet specific customer specifications. The winder plays a critical role in maintaining the dimensional accuracy and integrity of the paper, ensuring that each sheet or roll precisely matches the required dimensions. The precision in cutting and the ability to handle such enormous reels underline the sophistication and scale of current paper manufacturing. These advancements not only reflect technological progress, but also cater to the ever-increasing global demand for paper in various forms. Throughout the paper manufacturing process, environmental sustainability is a primary focus, with significant attention given to water management. Paper mills typically employ sophisticated water treatment plants to address the water-intensive nature of paper production. These treatment plants are designed to purify and recycle water through a multi-stage process. Initially, the water from the manufacturing process, containing fibers, chemicals, and other impurities, is collected and subjected to primary treatment. This stage involves physical methods such as screening and sedimentation to remove solid particles. The water then goes through secondary treatment, which is more biologically oriented. Here, microorganisms are used to break down organic matter in the water. This process significantly reduces the biochemical oxygen demand, BOD, and chemical oxygen demand, COD, key indicators of water quality. Following the biological treatment, the water undergoes tertiary treatment, a crucial step to ensure the water's suitability for reuse in the papermaking process. Advanced filtration systems, such as reverse osmosis, ultrafiltration, or activated carbon filters, are employed to remove the remaining microscopic contaminants. Additionally, chemical treatments, such as chlorination or ozonation, may be used to disinfect the water and ensure it is free from any pathogens. Once treated, the water is either recycled back into the paper production process or discharged, meeting the strict environmental standards for water quality. This comprehensive water treatment and recycling system not only conserves water, but also minimizes the environmental footprint of the paper mill by reducing wastewater discharge and pollution. In addition to water recycling, waste management is another crucial component. Solid wastes, such as sludge from the water treatment process and bark from the wood, are often repurposed. They can be used as biomass fuel to generate energy or as raw materials for other products, contributing to a circular economy model. Moreover, many paper mills are increasingly turning to renewable energy sources to power their operations. Solar, wind, and hydroelectric power are becoming more common, supplementing traditional energy sources and further reducing the carbon footprint of paper production. Some mills even generate their own energy by harnessing the power of biomass and byproduct gases, making them self-sufficient and less reliant on fossil fuels. These efforts in water conservation, waste management, and renewable energy use demonstrate the paper industry's commitment to reducing its environmental impact. By integrating these sustainable practices, paper mills not only comply with stringent environmental regulations, but also contribute to the broader goals of global environmental stewardship and sustainability. The main manufacturing phase of paper production is a complex and intricate process. It blends traditional papermaking techniques with modern technology to produce a wide variety of paper variations. This phase requires a high degree of precision and control, ensuring that the final product meets the strict quality standards demanded by consumers and industries alike. Quality control checks and standards are integrated throughout the manufacturing process, ensuring that the paper is not only of high quality, but also produced sustainably. In the final stage of paper production, the immense rolls of paper are encased in protective packaging to ensure their integrity during transportation and storage. These colossal rolls are substantial in both diameter and width, necessitating specialized handling and packaging techniques. Each roll is wrapped in a robust craft paper, a heavy-duty material that shields the paper against moisture, dust, and incidental contact that could lead to surface damage. The craft paper is tightly wound around the roll, providing a strong, moisture-resistant barrier that upholds the paper's quality in a variety of storage and transit conditions. Given their significant size, these rolls are not placed on pallets, but are instead moved by specialized lift trucks capable of handling their weight and dimensions. The trucks are equipped with clamps that securely grip the rolls without damaging the paper. Once packaged, the rolls are stored in a warehouse, where they await dispatch. When it's time for shipping, the rolls are carefully loaded into trucks destined for customers. The transportation process is meticulously planned, with each roll secured to prevent movement that could cause unwinding or other damage. This final packaging and handling process ensures that the mammoth paper rolls arrive at their final destination in pristine condition, ready for a wide array of uses in various industries. Paper production seamlessly blends tradition with innovation, yielding a product integral to various facets of daily life. Starting with sustainably harvested wood and recycled fibers, evolving through stages of meticulous processing, and culminating in the adept hands of end users, paper's journey is a testament to human ingenuity and environmental consciousness. Rigorous water treatment and renewable energy usage exemplify the industry's commitment to the planet. As each roll arrives, securely packaged, it stands ready to facilitate creativity, communication, and commerce, whether it be for printing important documents, crafting artistic expressions, or conveying critical information. Paper remains an indispensable ally in progress and expression.